again, what we discussed so far is film 360 video and then watch it on the headset, right? There's nothing else that a 360 video can really do aside from play. I mean, it's beneficial to be able to play it over and over again, be able to get some in-person career experience that you really wouldn't be able to give your students. You know, in the real world, we can't take a whole class down into the the pit, the confined spaces training for rural water. So if we want to get anywhere beyond just hit play and watch the video, that's where game engines come in. So, you know, all our apps, including the virtual video viewer, as soon as we have a level of interactivity that's beyond hit play, this is what we're using. And there's tons of them out there. There's a bunch of proprietary ones, but these are the main three that you know, small independent creators use. Major production houses use this as well. I mean, Unreal is actually created by a game studio, Epic Games. If you've ever heard of Ubisoft, who makes all the Assassin's Creed games, they use Unity. Godot's the newest one. I don't think any major studios have used it yet, but a lot of independent studios are building stuff with it. But the short version is these handle rendering the image in real time and then the logic and the functionality, right? So if we're gonna have buttons in there that do more, and in fact, you know, in the standard video player that's in there, you know, that's an app that just hits play and rewind and whatnot. That was probably built in one of these engines. So this applies to websites, the touchscreen on your car. You know, these are all built in game engines. So that takes whatever you throw in there and makes it so you can interact with it in real time. So these are the big three. I'm going to talk about Godot a little bit, even though we don't really use Godot, just because it's newer. And then the main differences initially is, you know, Unreal and Unity, like everything, you got to create a login, right? You want to download it and be able to go in and use it, you got to have a username and password associated with them. And there is various licenses. So a company like ours that, you know, does professional development, we have to have licenses for Unity production. Whereas if you're just using this internally, or when you're just getting started, you know, your organization has to get to a certain size. And as educators, you know, you're not producing things for commercial production, so you can just use personal license and it's fine. And those are all free until you do sell a product, and even then you got to sell a certain amount before they, you know, ask for a percentage. It's a good size. Until you're like really making money selling stuff with the game engines, they're not going to ask for a piece of it. So using it internally is fine. Your students can get, you know, personal licenses and then continue, you know, experimenting with these things. Other major differences, Unreal and Unity are big. They take up a lot of hard drive space because they have a lot of built-in features. They just eat up hard drive space. Unreal is the biggest. It'll take up to like 50 gigs. Unity is about half that size, usually 20 or so. So that's another reason people like Godot, because, oh my gosh, it's only 150 megs. It does the exact same thing, right? It renders the final image, and I can make stuff interactive. Yeah, it is. When you unpack it, it's only 150 megabytes, and it doesn't require you to have any login or license. It's open source. It's on a MIT license, so it's free to do whatever you want with for life. no issues there. But the reason it's so small is because it's empty.
Bare bones.
When you open it up, there is nothing in there. This is not in there when you start. Okay, this is a project that I built using their template. Yeah. So someone who is a computer science major and learning to write script and code might really love this because it's so open-ended. But you see on the left, we got a list of all the different types of items in the scene. If you see at the top, I have a couple things, right? I got the VR player, which is what can I do with my controllers in the headset. And then in the scene itself, I have a super basic environment and I have some items that you can interact with. And I didn't build this stuff. I grabbed it from the built-in asset library and just plugged it in. But there's really not a lot of organization options. Everything's just in this endless list. You got to kind of manually group it together, and it is super powerful functionality wise. So if somebody is writing code, this might, speak to them. It's super simple. There's nothing in the way. There's nothing there that I'm not going to use. And it is kind of friendlier than the other two when it comes to settings. Like, it makes it very, very simple, of literally just a checkbox of, am I trying to make something that'll run on a computer, or am I trying to make something that'll run, on the headset by itself or on the phone, right? And you switch between those and it does everything in the background. Whereas the other game engines, there's the whole list of project settings that you can get lost in. And some headsets or some hardware will have, a special tool that tries to take care of that for you. But Godot is like 2 clicks and it's going to work on the hardware you want it to. But what's it going to do? That is where it takes a lot more work at the front end.
And really, at the end of the day, these softwares all do essentially the same thing in the end. And you'll see several videos and slides of us showing off doing some things in Unity and Unreal especially. And so I want to just take a quick second to highlight some of the things that you're seeing on the screen here that will be consistent across all 3 of these game engines. Typically on the left, you have what we call our hierarchy. This is every single object that is visible in your scene. Your scene, that's your virtual world. That's where you're putting all your actual stuff, your 3D models, your graphics, even your audio clips will have some sort of reference in the scene. And if you want to select an object from that scene, you can click on it in the scene and it'll show you in the hierarchy. It's just kind of like your folders, your file explorer on your computer. These are all the things that I have in my project. You can nest them to other things, and it's a hierarchy, right? You can have what we call parent objects and child objects and children within those, and all sorts of things that you lay out in your scene hierarchy. Right in the middle, that's your main scene view. And then when we talk about any of the things that you actually want to do with these objects, that's that panel over on the right that typically is called the inspector. So if we want to, change the materials on a model, we might select that model from the hierarchy on the left. We'll see that model being selected in the middle on the actual scene view. And then we can adjust its settings in the inspector on the right, and then whatever that may be. So just kind of very quick orientation to what you're seeing in these images as a little primer for when we will inevitably see more of these in the future.
Another, main difference in using Unity and Unreal, which are the engines we typically work with, is they're bigger. They take up a lot of hard drive space, but that's because when you get in there, you're not starting at 0. You're starting much closer to finished. They both have some pretty robust templates. So if you want to start, creating full CGI, VR, interactive things, a lot of that stuff is already in there, and you don't have to set them up. You can just kind of alter them, to your own purposes. So on the left, I've got a couple examples of Unity's VR4. That object on the left is an interactive object. So I'm in the headset, I can reach out, touch it, and interact with it. This specific object is designed to stay in place, but you can turn it, right? And it'll only turn left or right. So
It's like a steering wheel.
Exactly my point. So that thing has already got all of its functionality built in, and it's got a little 3D model. The point is, we can take that thing and adapt it to our purposes as a steering wheel, or we can replace it with a doorknob or a valve, But the point is, that particular object that only rotates on a certain axis when you interact with it is already there, and we can use it to our own designs. And then, of course, menus. So if we want to be able to press buttons and have some sort of functionality, we have the ability to point and press that button already built in, and we're just changing what the button does. So on the right is the Unreal example, but same thing. You start a project, you say, I'm doing stuff in VR, and you start already able to go in and manipulate the environment. The thing that's the same across all three of these game engines is there's a huge community out there, and they love to share information and provide tutorials and build things and give them away for free. So, like I was saying, with Godot, you open it up and it's empty. There's nothing in there, but there's also that little asset library button at the top. Or in Unity, there's the Unity Store. Or in Unreal, it's called Fab now. And there's actually stuff for Unity, Unreal, and Blender, all sorts of stuff in there.
And that might include, individual 3D models. That might include a script or some sort of package with a specific functionality. Sometimes that'll even include entire template projects. So somebody has probably done a project similar to what you're trying to do, and just jumping into these online marketplaces. Marketplaces imply a purchase, and sometimes they cost a little bit of money, and sometimes they're free. It's really an amazing community who's been super dedicated to just kind of showing off the cool stuff that they do and saying, hey, you want to do this too? Here you go.
Yeah, there's always a free section. We always start with the free. And again, even after, 7 years of doing this is how we operate as well. If we're trying to work on a specific functionality, we go to the marketplace and see, has anyone already done this? Can we just, build off of what they have done, customize it a little bit? 3D models, do we want to take the time to build something out internally, or is there a viable option on the marketplace that we can just grab, save ourselves the time, and adapt it to our needs?
Yeah, I'll give you a great example. Literally just yesterday, I was looking in one of the online marketplaces. We were working on a project about doing some maintenance on a motor scooter, and I needed a tool. I needed like digital calipers to be able to measure the thickness of the brakes. And we've done a lot of projects that involve tools and tool usage in the past, but somehow we've never made a digital caliper. And so, the first thing I did is I went to, straight up, I just Googled it, honestly. If you just search digital caliper 3D model, including 3D model, will have all those stores pop up. And a couple options down, I found a really good free 3D model of a digital caliper. Just grabbed that, brought it into the project, and looks fine. I'm going to add a few more things to it, and I might have somebody on our team do a little bit of touch up. But oftentimes that is faster to have a starting point already, as opposed to starting from scratch.
And also, the community is very open. Like we go on YouTube all the time. If I'm trying to figure out how to do something, first thing I'll do is go, hey, does anybody have a step-by-step tutorial on how they did this? And more often than not, yes, it's the case. People are happy to share the information. So as professional developers, this is the way we work. We go and see, has anyone else already done it? And are they willing to share how they did? And that gives us something to work off of. And again, we're gonna give you some resources. We have a Unity project and an Unreal project that have all the ins and outs of doing a 360 video interactive application prepared for if you want to shoot your own video and bring it in and plug it into these game engines. They're already designed to do that. So the main difference between the way you use your headsets now versus if you want to actually make interactive apps in a game engine is it's got to be in developer mode. That's the only way to access the apps that you've built.
If you're a school and you've gotten headsets through an organization like Labaki or InCare or whoever, typically they're going to be providing content to you in some way that will already mean that the headset is set up in developer mode. But if you, as a school with a media program, want to go out and just buy your own headsets, right? You could go to Best Buy or Amazon and just grab a few headsets. You can still do fundamentally the same thing. The only thing is you'll have to put it in developer mode. Like Vinny was saying, that's just the thing that opens the door to let you put your own content onto the headset.
And it's literally just clicking a button on the app that says, yes, I want to be in developer mode. And that will make it so that you can access, the apps that you load directly. So in general, you have a headset, you have a USB-C cord to connect it to the computer, and the computer is going to be where you're building all this stuff. Meta has its own bit of software for talking to the headset, and that's it. Once you've got an app built out, you throw it on there, and then you can run it. This is another thing that we will talk about more. SideQuest, free bit of software that does the same thing, talks to the headset. I demonstrated that in the first video of using SideQuest to throw our 360 videos directly onto the headset rather than going through the Manage XR route.
Yeah, whenever you connect a headset to your computer, you can use SideQuest, this free tool, to load videos directly onto your headset. You can also, if you've got your headset plugged in, just open up your file explorer usually and navigate to the videos folder on your headset and dump them there. But anytime you are installing an actual VR app, maybe you've installed an app on your PC before. That's a .exe file. It's an executable. I think Mac calls them DMGs. If you're putting an app on your VR headset, that is called an APK. It's like an Android package, I think is what that stands for. But it's an app. APK is just it's an Android app, and you would use a tool like SideQuest to install that app from your computer onto the headset.
I'm gonna brush over this pretty quick, but the point is that in the game engines, in Unity and Unreal specifically, there's a lot you can do without ever having to actually write, custom code. Obviously, we have our controllers, and when we push buttons, something happens. So that's an aspect of the design that is, hey, this is an interaction. Well, this is an interaction. So the stuff that's already built in there, we can always just make a copy and say, cool, I'm going to make a control that you're not using. So in the default version of Unreal's VR experience, your right thumbstick is for moving forward and backward, and your left thumbstick is for turning left and right. And so they're not really using up and down on the left controller for anything. So I could make a version of their controls that says, yeah, when I do the left joystick up or down, execute this logic. So what this is called visual scripting. So again, this is like writing code in the background, but we're not actually having to learn C++ or C# and type it out. And all of the game engines have a version of this where instead of typing computer script language, it's just this kind of a flow chart. So on the top left, that's hey, I have pressed up or down on my left joystick, and that's just going to give you a number, right? All the way up is +1, all the way down is -1, and then everything in between. And so I'm really just taking that number and saying, either of these objects, if I have it in my left hand or my right hand, take a look at the object that I'm holding and then change its scale. So built in is all these interactive things already inside the environment. And all I did was say, anytime I am interacting with one of those things and I press the left joystick, either make them bigger or make them smaller. Point being, you can do a lot of customization and changes without ever writing scripts.
And, like Vinny was saying, you'll have some degrees of visual scripting in the different game engines that you're using. And visual scripting too, or really I should just say VR development that doesn't involve coding directly, can take a number of forms. And in one of the projects that we'll show, we're going to pull up a project template that we've developed that demonstrates how you could actually set up your own VR tour using 360 videos or 360 panoramic images. And it is not necessarily a flow chart. It's basically selecting a thing and filling in your images in certain places and changing some settings. But the point is, you're not coding. You don't have to write code. It's just where you set up the logic using a piece of functionality that we've already developed. And in general, that is how we like to develop. Vinny was saying very early on in the presentation that we've spent a lot of our time as Labaki developers making our future jobs and our future selves very happy, very easy. We have what we call our function catalog, which is, all of these different scripts, essentially. Somebody wrote these out in C# or C++. And it's a script. It is a thing that, if I've got a box and I want to track when something enters this box, that can be a script where I say, whenever this box was entered by an object, do this thing. And also, if I want, check to see if that object that entered this box has this in its name, and only do those events if that happens. So that is one script. But you can use that for, and we have, thousands and thousands of different purposes. So thinking about how can you abstract a simple bit of functionality into something broadly useful, into a little puzzle piece that you can build out a much bigger set of interactions.
Yeah, and again, all of these resources are going to be accessible. So what I'm going to show you now is our Unity template project. So we have this project that's available to you. I have the instructions, laid out step by step in text format with a lot of pictures, and then they'll have this video as well. That's step by step. If you want to take our Unity project and put in your own 360 videos and make an interactive tour, how do we go about doing that?
And, this particular project that we're about to show, we have a number of schools that we've shown this template to. And the whole idea is that if you have a 360 camera and you want to do any sort of virtual tour, virtual walkthrough, maybe even adding some quiz questions or some additional functionality, you can use this project to achieve that. Essentially, this project means that you can make your own Google Street View, is what it is. Right? If you've seen Google Street View, it's just panoramas. It's a 360 image all around you, and you can jump from one spot to the next. So that's all it is. It's a virtual tour in that way, and we can add text and videos to go along with it.